on the recording, make sure that you keep your video off. So basically, this webinar the aim is to just give you a general overview of the TextGen project. We're going to look at sort of what you see when you run up the user interface for the first time. Try and look at some of the things that I'm aware that people miss, and just give you a general overview of the project, and look at how you can generate some 2D woven textile models, and how to customize them to suit what you're trying to create. So the TextGen project, it's basically it's software for geometric modeling of textiles, and that can be woven textiles. The way that it's set up means that you can do, say, knitted textiles or braided textiles. Because of its flexibility, you can change it to do different things. And it's basically for modeling textiles at the mesoscale or the unit cell level. And typically you might create textiles such as the ones that you can see here, a 2D textile here, or a 3D woven textile here. And when you download TextGen, the first thing that you'll see is the user interface. But it's more flexible than that. There's a scripting library that you can write scripts in Python, and be much more flexible about how you create your models. It's a preprocessor, so it will generate meshes for you, and in some cases set up input files so that you can then run simulations using those files for finite element analysis or CFD. And typically, because the yarns are modeled as a solid, but taking into account the fiber properties, you would use a microscale model to simulate the yarn properties and feed those into the mesoscale models in TextGen. And then the material properties that you might predict using TextGen, you would then feed into a component or macro scale model. So the TextGen project, the main place to go to find out about TextGen would be the web page, and the link is there for the main TextGen web page. This basically is your sort of go-to place for information. There are details of whether, like the webinar here, and new releases, but there's also the link to the download page, and information about how to install the software, how to install the source code if you want to actually build the source code yourself. And in this documentation section, there's a user guide, there's a reference for the scripting facility, and there's a page of publications. So there's all sorts of information in there. There are some tutorials. So that's a good place to go if you want to find out information. And there is some information about applications. So if you want to download TextGen, the download files are available on SourceForge at the link given here. When you arrive at SourceForge, you get to this page. The big green download button will download the most recent bundled version, which includes Python. If you go into the Files tab here, then you will get access to the different versions of the software. So you'll get access to the version without the bundled Python, and also previous versions as well. The source code for TextGen, it's open source. The source code is stored on GitHub at the repository here, and there you can download the actual code and build it if you want to do that. If you have bugs or issues, you can report them in the Issues tab on GitHub. And if you're a TextGen user and you find a bug, please do report them, because we can only do something about bugs if somebody tells us that they're there. So please do report any bugs or issues if you find them. And there are a couple of places. There are sample scripts on GitHub as well, and there's also a scripting manual. And as I said before, the instructions for compiling on both Windows and Linux are given in the page on on the website. If you've got queries about TextGen, you can look at those via the TextGen forum, and that's a really useful source of information. You can see questions that other users have asked in the past. Normally pick up questions fairly quickly if you do post them. You can go and look and search on the forum without registering. But if you want to ask a question, then you will need to register. And when you register, you will need to wait for that to be improved. We just had a problem with spam. So if you want to ask questions, then it might be a sort of a day or so before we get to approve the registration. But after that, you can ask questions. So this is just an overview of the TextGen structure. It's a bit of a sort of busy picture, but the gist of it is that TextGen is written, the main code is written in C++, and it's stored in the TextGen core, and it makes use of various third-party libraries for various parts of the functionality. But the main guts of the program, if you like, are written in C++, and then it's wrapped using a program called Swig to create a Python interface. And the Python interface enables you to communicate with the program called the TextGen functions using Python scripts. And there's an export library which enables you to create step and digest files. There's a rendering module, which is what you see in the center of the main TextGen user interface window, and that uses the visualization toolkit library. And then there's the TextGen user interface, which the dialogues and everything are created using a program called WX Widgets. And essentially the user interface communicates with the TextGen code via the Python interface. And one of the things to note about this is that although when you download it, you may well just use the user interface and use it as it's built, because of the way it's constructed. If you say want to run TextGen on an HPC, then you can just use the core library module with the Python interface and just have that installed on an HPC and just call the functions. You don't have to have built the renderer and have the user interface as well. And so it will run on both Windows and Linux. That's what I'm going to say about that one. This is a bit of a sort of scary diagram, really. It basically shows you the guts of what's in the TextGen core, and the function, the classes and how they sit together. So you start off with a Textile class, and that contains yarns and nodes and sections, and we'll cover some of these things in the next few slides, but that's maybe just a slide that you would use for reference and look at later. Excuse me. So we're going to take a look at TextGen itself. So if you download and open TextGen, you'll probably see something that looks like this. There's a controls window at the side here, which basically to a large extent duplicates the functionality that's in the main menu, although especially in the modeler tab, there are some extra functions. It's worth, when you first run it up, check the window function, and if you check outliner, then you'll get this extra window at the right hand side, which is really useful, as we'll see later. So worth taking a look at that and making sure that you've got that window live. You'll see what it does in a moment. And then at the bottom here, we've got 3 tabs. So the first one is a Python console, and that is actually a Python console. So if I type something like A is 1, B is 2, and then do A plus B, it's executing Python code. So if you want to execute Python functions for whatever, or execute some of the Python functionality in TextGen, you can do that from the Python console, and we'll see that as we go along. The Python output shows you what Python functions have been executed within the user interface. So at the moment, all that's been done is that the various TextGen modules have been loaded. And then the TextGen output, there's nothing in there yet. We've not done anything. But that's a good place to look. If something's gone slightly wrong, it's worth looking in that TextGen output tab, because that's where any error messages will be flagged. So if I just, for starters, just create, we'll come back to do this in more detail in a moment, but create a Textile. So you'll see now we've created a TextGen model of a 2D weave. This has used the wizard to automatically create it for us. If you look in the Python output at the bottom now, you can see a list of various functions that have been executed. So this is useful if you want to get the idea of how to use the functions in the API. Then you can do some of the things which are done automatically from the user interface and look and see what code's been executed, and then you can duplicate that code in your scripts. So you can see in the outliner now you've got a list of the different yarns and nodes that have been created, and we can look at the different renderings. So left click on your mouse will allow you to move the view around. If you use the center button, then you can pan, and the right button will allow you to zoom in and out. And if we look at the rendering, then we've got various render options. The X-ray allows you to see the mesh that's created, and then you can render the nodes and the yarn paths. So that gives you different views of the textile that you've created. Okay, so now is look at some of the modeling theory behind TextGen, so that it's easy to just create a 2D textile using the wizard, but you'll get more use out of TextGen if you can understand what's going on behind that model. So essentially, when you generate a textile, you initially create an empty textile, then you add some yarns to it. Then you specify a domain which shows the area of the textile that you're looking at, and then you'll output some data. Typically, you might just save the model, or you might output in a form that you can export to Abacus or something. And essentially, the 2D and 3D wizards automate these first three steps for you. So they basically will do these steps and create the form that you've said you want to create. But we're going to look at how we do that in a little bit more of a manual way, so that you can see and understand what's going on. So the first thing we would do is create a textile. So if you go into TextGen, if we're in the Textiles tab, if we just create an empty textile, we can put in a name. I'm just going to put test and click OK. And you can see now we've just got, you can see the axes. We've got the name at the top in the tab at the top here. So we've now got two textiles in our user interface. Or this one's not got a textile created yet. And you can see that the line of code that it's executed is add textile with the name of test, and it's called the C textile class. So when you create yarns in a textile, you basically create a set of master nodes. So in this yarn at the top that's been created here, we've got 3 nodes here, here, and here. So you create a set of master nodes at different points along the textile, and then you choose an interpolation function for how those nodes are going to be joined up. And there are three different sorts. You can have a Bezier spline, a natural cubic spline, and a linear spline. And they may or may not be periodic to enforce continuity of the yarn across repeats. So that looks something like this. Go back into TextGen. So if I go into the modeler window now, I can just create a yarn. So this gives me the default window to just create a yarn, and the default is starting at the origin 0, 0, 0 and ending at a value of x is 10. So it'll create a yarn that's 10 units long, and you can specify the number of nodes. So we're going to change that to 3 here. So that just creates one yarn, and you can see in the outliner window you've got one yarn with 3 nodes. And I'm going to just select that yarn. You can left click on there, and you can use these arrows to drag the coordinates of the node. So if I select this one and drag it upwards, and you can see in the left hand box, position box on the left hand side of the screen, you can see the Z coordinate changing. The X coordinate is 5, it's at the midpoint, and so you can see the Z coordinate changing there. The other thing you can do is if I knew that I wanted the Z coordinate to be 2, I can just type that in and it will change it for me. So if I want to change the way that the interpolation is working, how TextGen joins these 3 points up, I can select the node by left clicking on the yarn and then take the interpolation, and you can see at the moment I've got Bezier spline interpolation selected, and at the moment it's periodic, and you can see that, oh, let me just cancel that so I get it straight so that we can see more easily. It's periodic, and you can see that I've got the same cross section at either end of the yarn, and so if this yarn were repeated in the X direction, then those two ends would join up into one continuous yarn. If I unselect the periodic, you can see that that has slightly changed how the interpolation has worked, and that continuity across the two ends hasn't been enforced now. So if I wanted to repeat this yarn, then I would get a discontinuity where the yarns join up. So typically when you're creating a textile, you would probably want it to be periodic, but there may be some occasions when for some reason that's not what you're after. We'll just show you the natural cubic, how it changes the path. And if I make that periodic, then you can see we've got the continuity across the two ends again. And then the last one is the linear, which is probably the least useful. Like, there may be occasions when you want to use that. It's there, you can use it, but probably the least useful. Let's change it back to the Bezier. Okay, so we've created one yarn with 3 nodes and chosen how we're going to interpolate, and you can see that it's created sections at each of these points in between. So then we having created the yarn with the interpolation function between the nodes, we can specify the cross section along that yarn. By default, as you saw there, it creates the yarn cross section as being constant along the whole length of the yarn. But you might want the cross section to change, and there are 2 different ways of doing that. You can choose an interpolation method. So we can either have constant, or we can choose to interpolate between the nodes. So at each of those 3 nodes, we could specify a different cross section, or interpolate between positions. And so you can specify at any position along the yarn. It takes the yarn as being normalized, being one long. So you can specify at any position between 0 and 1 what the cross section will be at that point. And so we have various different cross sections available. Generally speaking, you would create a yarn would be created as with an elliptical cross section or circular ellipse, the two axes the same. Lenticular is sort of lens shape, and you can see one of the things you can do with the lenticular is specify an offset so that the widest part isn't necessarily in the center vertically. There's a power ellipse. I'll just go to the next slide to show that, which is this special shape, which is we specify a power, and as the power decreases, then the shape will tend towards a rectangular shape, and then it will go towards an ellipse as the number increases, and as the power increases even more, if n was 2, then we go towards a lenticular shape. So that gives you quite a bit of variation of the shape. And one of the things that you can do with the power ellipse also is to specify an X offset so that the widest part of the shape isn't necessarily at the center horizontally. There's a hybrid shape where you can split the shape into different sections and specify a different shape for each one. So in this case, I think we've got an ellipse specified in this red section and a power ellipse for this other section. So if you've got sort of a slightly weird shape, but you can see how you would make that up, you can use the hybrid to set that up. There's a rectangle section, which you might say, well, why don't you just use a power ellipse with a power of 0? The reason why it's better to use a rectangular section is that when this is meshed to create volume mesh, the rectangular shape will create nice squared mesh for you, where if you use the power ellipse, you'll get slightly weirdly shaped mesh. So if you do actually want a rectangular shape, use the rectangle cross section. You'll get better results. And then there's also a polygon section where you can create a set of points around the circumference of a shape, but that's only available by scripting. So you'd have to write a Python script if you want to do that. It's not accessible from the user interface. So if we take a look at creating some sections. So in order to create a cross section, you need to select the yarn, and then you can select the cross section, and you can see that at the moment this is set up to be constant. So if I go edit section, at the moment it's an ellipse with a width and height of 1. If I want to change that, say I wanted to create a lenticular section and make it too wide, press OK. So you can see now it's changed the cross section to that lenticular section all the way along. If I wanted to change it so that it was interpolated between the nodes, so now you can see it's given me a list of my nodes. So if I select node 1 and edit the section, then I might say I want that to be a power ellipse. And make it 5, and you can see that the shape that you'll get is reflected in the dialog there. So if I change that now, and so you can see now I've got this shape which is still the lenticular section at the ends, but it's changed to that. That's maybe easier to see when it's not. So you can see it's changed that paralleliptical shape in the center. And so if you wanted to choose the interpolation between sections, then I could specify different shapes at different points along the yarns as well. So having specified your master nodes, the way that you're going to interpolate between the nodes, sections at various points along the yarn, TextGen then internally generates the yarn surface. And what it does is when it does the interpolation, it creates a set of slave nodes. So if you look at one of these diagrams here, you can see you've got the different sections going around the circumference, and internally TextGen generates a slave node at each of those points. So if you have a low resolution, it will create fewer of those slave nodes than if you've got a very high resolution. And having generated the slave nodes, it then interpolates a cross section at each of those slave nodes perpendicular to the orthogonal to the yarn tangent at that point. So if you have got a changing cross section, then say if it was going from a circular to a more paralleliptical shape here, then it will interpolate the shape at each of those slave nodes along and generate the surface. And you can change the resolution so that you have more control over what the surface mesh looks like, and also these meshes are used to create the volume mesh if you create a volume mesh of the yarn. So just show how you can change the resolution. So at the moment, I think the resolution is the number of slave nodes along here is 20, and it looks like the number of points around the edge is probably 40. So if I want to actually be able to change this textile from the console, I can say textile equals get textile, and you need to use the name of the textile that you created. In this case, it's just test, and then say yarn equals textile.get yarn. So these are using the functions in the Python API, and it's yarn 0. And then there's a function called set resolution. So this function can either take 1 or 2 parameters. If you send it 1 parameter, then it specifies the number of points around the yarn, and then it will calculate a suitable number of slave nodes along the yarn. Or you can use 2 parameters, and in which case the first parameter specifies the number of slave nodes, and the second parameter the number of section points. So if I say yarn.set resolution, and so I'll say 15 and 20. If I refresh the view, you can see now I've got 15 slave nodes along here and 20 points around the yarn. And you can see as you, if I zoom in, you can see that the yarn path is essentially straight in between each of those slave nodes. So if you want to have a very continuous looking yarn, then you need to increase the resolution, the number of slave nodes, but you have control over that. So at the moment, we've just created one piece of a yarn, but how do we create that so that it's in a textile that you can create a large area of your textile? And the things that you can use to do that are you define a repeat. So having created the smallest part of your yarn, the smallest repeating part of your yarn, you specify how that's going to repeat by specifying a set of vectors. And then you can specify a domain which says what part of that textile you're going to create, to look at. So by creating the set of vectors, so in this case, these are with default yarns, which were 10 long. So we've created one repeat vector, which repeats every 10 in the x direction. So you can see that this repeats every 10 in the x direction. And then another one, which is 5x, 5y. So that repeats this 5x and 5y. So it repeats diagonally, essentially. Normally, you would aim to have both ends of your yarn with the same cross section, so that when the repeats joined, you end up with what looks like a continuous yarn. But this is just for illustrative purposes. It shows up nicely how the repeats have worked by just having slightly different sections at the end of each yarn, at either end of the yarn, but normally you wouldn't do that. And then the domain is basically a set of planes which restrict the textile to a certain region. Typically it's a box, and also typically it's a unit cell, but doesn't necessarily have to be. In this case, you can see that a domain has been specified, which gives a few repeats of the yarn. So if we look at our yarn here, we know that we can see that this is at 0, 0, and this is at 10, 0, 0. So if I want this yarn to repeat in the x direction, I can select the yarn and create a repeat, and I can just type these in. So I can say I'm going to have, and I might also want my yarn to repeat, or we can do what was in the other one, have it 5. So you can see at the moment, nothing apparently has happened, and that's because I haven't specified a domain. So if I specify a domain by creating a box, I'm going to say this is going to go from 5 to 20 in the x direction. I'll do 5 to 20 in the y as well. And then in the Z, I'm going to go from -1 to 4. So you can see now my actual yarn that I've created over here is over here, but my domain box I created was in a slightly different place. So if I render the domain, you can see that that's the area of the textile that I'm looking at now. And if I export, then that is the area of textile that would be exported. If I want to create a larger area, then I just make a much larger domain. Or if I want to create just a unit cell, then I'll make it so that it's just the same as one repeat of the yarn. But you've got flexibility over what portion of the textile you look at. And the final stage for setting up your model so that you're in at a point where you can export to do some analysis is to set up the yarn properties and the matrix properties, and that's in the modeler and assign yarn properties. If you want to export volume fractions for the elements in the yarn, then you need to either specify the total fibre area, or the fibre density and yarn linear density, or the fibre diameter and number of fibres per yarn. It can calculate the volume fraction from any one of those three options. Basically, you don't need to have all of those properties specified. And then you can specify the mechanical properties, the Young's modulus, shear modulus, Poisson's ratio, and the same for the matrix properties. So if I go back to here, so if I select my yarn, then I can assign properties, and so if I wanted to say there are default values specified, so if I wanted to change that, so I wanted to change that to 2000, oops, and you can actually change the units here. So I might have that in gigapascals, and then TextGen will process the units, and when it outputs, it will output them all as, I think it's SI units, but make sure that they're all consistent units depending on what you specified here. And then if you want to specify the matrix properties, as I was doing this presentation, I realized that this is a ridiculously small box. So there is actually now an update, and we'll go out in the next release of TextGen that allows you to expand this box a bit so that you get all three options in the same one, but you can in the same way input the values there. Okay. So let me just have a quick. So we've created our TextGen model. Now we want to save it, and this saves in a file called a TG3 file, which is basically just a renamed XML file. There are 3 different versions of the data that you can save. The minimal saves the textile data, which just has the information that's generated by weave classes. The standard creates the textile and the yarn data, and the full creates all of the mesh data as well. And the other thing that you can do is if you're trying to write a paper or something and you want to render the save the screenshot of a TextGen model, then you can do that. So we'll just show you those. Stop rendering the domain. I'll go to this one. So if I want to create to save my TextGen file, oops, not that one. I'm just going to save that as a plain weave and replace it. And if I open this in a text editor, it looks something like this. So you can see that it's basically just an XML file, and it's created a 2D weave. You've got the domain, you've got all the planes that are used to create the domain. You've got the units for the different properties, and then the locations of the master nodes. And you can see that it's a sectional ellipse, and so there's all the information that's basically saved with the in the same format as the data in the TextGen model. And you can actually edit this. So if I sort of look along here, so you can see here I've got the number of slave nodes is 50 and the number of section points is 40. If I thought, oh well, actually I don't need that many slave nodes, I'm going to just change it to 20. I can do that. If I save that and then reload my model, then it will have changed the number of slave nodes. So you can actually just edit your model in the TG3 file if you want to do that. Just keeping an eye on the time. So we've seen how you can just create single yarns, and clearly you can build those up to create a weave pattern, or whatever form of textile you want, knitted textile, whatever. But there is automatic generation of 2D weaves, and this uses the cTextile base class. But then for 2D weaves, it then has a textile weave class with the textile 2D inherited class that's inherited from it. For the 3D weaves, there's a textile 3D weave class with the different types of 3D textiles, but we're not going to be looking at those today. So the textile weave class basically stores information about the weave pattern and then builds somebody put their microphone on. Thanks. And then builds up a pattern of information and automatically generates the weaves from those. So the 2D wizard in the user interface allows you to create weaves using this 2D class. So you specify the number of warp and weft yarns, the spacing and widths, etc. And then it will give you a dialog, which essentially is building up that pattern in a 2D array. So if I've clicked on here and here, that corresponds to values in this cell array. So these are the positions 0, 0, 1, 0, etc. And at each of those points, it's the crossover points where the yarns cross over. It stores whether the yarn at that point is a warp or a weft, or what we call a Y yarn or an X yarn. So at this point, the location is 1, 0, but the values stored in the array at that point are 0, which says it's a yarn parallel to the Y axis, which is a weft, and then an X yarn or a 1, and so it stores 0, 1 here. At this point it will be 1, 0, and from that pattern of zeros and ones at the different locations, it then builds up a yarn, a textile. Right one. So that was basically what we did when we were creating the textile here. But maybe, actually, I'll just do the example here, and that will show you in more detail what that will look like. So if I was trying to create this textile that's shown here, you can see that in this case, I've got different widths of warp and weft, and oh, no. Different widths of warp and weft, different heights, and different numbers of yarns per centimetre in the different directions. So clearly I can get part way with the wizard to do that, but I might have to do some editing, and I'll show you how to do that in just a moment. So one of the things to realise about the 2D wizard is when it asks for the textile thickness, that is basically the thickness of the two yarns put together. So in this case, what I'm going to do is I'm going to create a yarn, a textile which is 0.5 thick, and then I'll edit the yarns afterwards. And I'm going to take this number of yarns per centimetre, so it will be a yarn spacing of 1 millimetre, and I'm going to create it with 0.9. So if we take a look at that, so if I go back to the textiles and do a new weave. So and this example was to create a satin weave with 4 yarns. So I'm going to create 4 yarns in the warp and weft. So I said for that 10 yarns per centimetre, I'm going to leave the yarn spacing at 1. And the yarn spacing for the 2D wizard is the distance between the centre points of the yarns. So I'm going to do a width of 0.9 and a fabric thickness of 5. And I'm going to take off the refine. And try that. And so if I don't change any of the parameters, then I end up with something which has similar widths and spacings in all directions, and the yarns are all the same size. But if I go back and do that again, and do I'll leave the refine on. So I create the pattern, but in this case, what I'm going to do is the warps I've got as 0.9 with 1 spacing. Is that the right way around? But they wanted to be 0.3 high. So what I can do is, what I did there was I'm using the left mouse button and shift so that I can select multiple yarns at the side, and then I can change the height. So I'm going to change that one to 0.3. And then if I select the ones across the top, then I can set the yarn width as 0.7. The height to 0.2. And the spacing, in this case, it was 13 yarns per centimetre, which comes out at, find my bit in my, what's the number? 0.769. So you can see that it's changed the spacing and the size of the yarn. So I've got one that's thicker than the other. And if I do OK now, so you can see now I've got different widths for my different yarns, different heights, and it's refined it. And so that's changed the cross sections so that it's not intersecting. We're getting short on time, so I'll just do one last thing that I was going to show. So if I do a standard, actually, a standard plain weave 2D default model, and do X-ray. If I render the intersections, then you'll see what it does is it calculates the intersection at each of the surface, each of the crossover points on the surface nodes. And you can see that if I look in the output, it's found 2,506 intersections. The maximum intersection depth is this. So what I can do is, if I use the same weave again, but this time do refine, and I can specify gap size. So if I want to enforce a gap in between the yarns, I could put something in there, but I'm just going to leave that at 0. And if I now render and render the interference, so you can see now we've got no intersections. And what you can see is that, let's just, the cross section has changed, and what this does is it changes both the rotations of the yarns and the cross sections so that they don't intersect each other. So if I select one of these and look at the cross section, you can see that it's changed it from constant to different cross sections at the different nodes. And if I look at node 0, when I go edit section, it clearly it isn't a parallel ellipse that's in a circular shape, and that's because what it's done is it's changed it to a polygon section, which you can't edit from the user interface. So I'm just aware of the time. I think what we'll do, because I was going to show an example of creating a manual 2D textile, but I think we'll leave that for today. To give people a chance to ask any questions if they want to. And I'm planning to do another webinar looking at exporting TextGen models for simulation, so how we do the meshing, what formats we export models in, and some example use cases, provisionally the 27th of April, but we haven't finalised that, but we'll put out information about that closer to the time. And so that's about